All right, we'll start off with that law of exponents for powers. And the law of exponents for powers is this. It's a little more complicated, but nothing too bad. I'm going to make it simplified. A to the m, okay, so a raised to the m power, all of that raised to the n power. Do you guys remember what that's equal to? A to the mn, or a to the m times n. Yep, you multiply those two. Now, this is not the same thing as the law of exponents for multiplication or division, because what are you doing in multiplication law? You're adding exponents. What are you doing for the division law? Subtracting exponents. What are you doing for the power law? Multiplying exponents. So those are not the same. But how do you distinguish between the two? Well, can someone maybe give me that? Like, how do you know that you're using the law for powers or law for multiplication? Because those sound pretty similar. Anybody? And I told you this a little bit ago, maybe. Okay.
Would the exponent be on the outside?
Yeah. A good clue is that the exponent is outside a set of parentheses. That's how you know you're using the power law. Okay, so that's our power law. And let's get an example here. So you guys, wow, that's not going to work. We'll get an example here so you remember how to use it. And then we're going to expand that because there's that third law, but it's almost like part of that law up there already. Okay, let's go with a different background. How about that? I found, yes. Mandy, can you hit that little middle button? Just be careful. Okay, the first one I'll give you is x to the third raised to the second. X to the third raised to the second. And by the way, that 2, you see how it's a little bit above the 3? You see how like on a level it's a little bit above? It doesn't have to be. I could have written it right on the same plane. They're the same thing. This is how you write it. Okay, but what do you get here? X to the? Because x to the 3 times 2 is x to the 6. Okay? That's the law of exponents for powers. We call x to the third a power. So that's why we call it the law for the powers. Okay, everyone good on that? I'm going to expand it, though, to a new designation, but it's not, hopefully you can get it. Okay, it's kind of similar. X to the third over y to the fourth. And that's going to be raised to the second. What does that mean? I'm asking you a deep question to start. What does that mean? Like, what does this to the second power mean?
X to the 6.
Close. Not everything by 2, but if these had the same base, you could subtract maybe those, but yeah, don't subtract those right here. What does this mean? Like this is a bunch of numbers. Yep.
You're going to multiply the 3 by the 2 and the 4 by the 2.
That's it. But this is why. So this is why. Write this down. I'm not going to have you do this from here on out, but this is what this designation means. It means x to the third over y to the fourth is being multiplied by x to the third y to the fourth. It's being multiplied by itself. And does anyone know what that would give me? Think of it. What would you get in the numerator if you multiply those two? X to the sixth, right? Because you got 3 x's, 6 x's total. And you'd get on the bottom y to the 8th because you have 4 and 4. Not that. Okay? That would be your final simplification. And then Sophie gave us a shortcut. Instead of having to rewrite it as its multiplication, what do you do with those exponents? Multiply those two, x to the 6th. Multiply those two, y to the 8th. Everyone okay with that? You try. Here's another one. A squared over b to the 5th raised to the third power. Go ahead and give me that simplification using the law of exponents for powers. This is a big power. And you don't have to write it out the long way. You just should go through it pretty quickly. All right, Cole, what'd you get? Yes. A to 6 over b to 15. Good on that? Okay, let's get a little more complicated. Okay, these two right here. When could I subtract these? Not right now, but I could if something were true.
The same variable.
If you had the same variable. If you had a and a, yeah, you'd do 6 minus 15. But what would that give you? 6 minus 15. A negative. Have we talked about negative exponents yet? Kind of, right? Have we gotten in depth with those? Today. Wait, what's today? Tomorrow I'm having my baby.
Yesterday was Saturday.
Thank you, Max. Thank you. Yeah, no. And you're not applauding me. You're applauding me, I should say. You're just happy for me. Okay. Well, let me give you a present here. X to the negative second over y to the negative first raised to the negative third. Gasp in horror because you just had 3. Now, I didn't just introduce you to negatives. I just slammed you with negatives.
Can you have
No.
Okay, Annie, what'd you get here?
I said x to the 6 over y to the 3.
Yep, how'd you get that?
I multiplied like 2.
What did you multiply? I'm looking for keywords. I multiplied.
I multiplied 2, negative 2 and negative 3.
Yeah, what are those called? The
Power.
exponents. Yep, specifically exponents. So I got positive 6. And then she multiplied negative 1 times negative 3, positive 3. It works for those numbers too. So these exponents have to be integers, and you can get positives or negatives, right? Don't be afraid of either one. Thank you, Swollen. Okay, last one on this, and then I'll give you a couple of practice, and then, you know what, I think I'm gonna slam you guys because you guys are bright. You just woke up. Your energy's going there. How many of you had breakfast? Good. Thank you. Breakfast is the most important part of the day. Do you guys realize break, fast? So what were you doing all night?
Breaking fast.
You were fasting. No, you were fasting. Your body was not taking in food. Hopefully. Unless you came up with some weird way of eating while sleeping. And then after that time of not eating, you break your fast. And so you eat breakfast, and now you get food. And, oh man, it's cool about the science of sleep. You need about 9 hours of sleep. Like a teenager needs 9 hours of sleep. And usually what happens is teenagers get less time of sleep. So I, as an adult, need 7 to 8. Or sometimes I feel like I need more, but 7 to 8. But why do you guys need more? You're growing. Because you're growing and you need to develop still. And the thing is, listen, in your DNA, there's a potential for whatever. I don't know what it is. Like, I can't look at your DNA. Even if I looked at your DNA, I wouldn't know. Leave that to those who are specialists. But your DNA says you are capable of getting this tall, of being this intelligent, of being this skilled in different areas. But if you're not taking care of your body, you never reach that pinnacle. And so your body still grows, still develops, just not as much as it should have. So get sleep, get food. Food, I think you covered. Sleep is the one I think we're lacking. So don't limit your potential. Okay, I should have been 6'5", and look at me, because I didn't sleep enough. No. I'm 5'11" and 3/4.
Really?
Oh, feels bad about shoes.
Oh, I'm 6'2".
Yes.
Yeah. Swivel doesn't do me justice. I'm taller than I look. Okay, and I told you about my brother. My brother was 6 foot. I think he was 6'1", and then I started catching up. I was like 5'10", 5'11", and then when he was 22 or 3, he got a couple more inches to him, and I'm like, what? How did that happen?
No, it's a degree.
Oh yeah, that's a 0, and maybe I'll make it clearer. Okay, you're going to do the same thing except you have a number here. You have 3. So what do you think you're going to do with 3? You're going to raise it to the 5th power. See? What exponent does 3 have? 1. So the law of exponents for powers, not the law of numbers for powers. So are you multiplying 3 by 5 or 1 by 5? 1 by 5. So you should get 3 to the 5th. And then I am going to give you some, but they're not going to be that high where you actually have to figure it out. How would you figure out what 3 to the 5th is? What'd you do? 3 times 3 times 3 times 3 times 3. And you could do it 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. 81 times 3 is 243. Mm-hmm. So you can do it that way. But look at this. C to the 0 times 5 is 5? 1? Let's see. And then D to the 10. Because you did 2 times 5. Now, what you could have done to start off with, and this is where you have options. What is C to the 0? 1. What's C to the 0 again? 1. What's 1 to the 5th power? 1. So really this 1 could have dropped out at the beginning, or you could drop it out at the end. But your final answer, since we know it's 243 over D to the 10th. That would be your final answer. So 243 over D to the 10th. Now, I've reconsidered my decision about negative exponents. In Algebra 2, trust me, you're going to get negative exponents, and they're going to slam you with them. It's going to be like, I remember distinctly, we took our course, the way we took it was Algebra 1, then Algebra 2, then Geometry. So we took Algebra 1, and we passed. Good, oh, we're all good. Next year you come in. The first chapter, I remember, were these kind of problems, but they had negative exponents. And they're all over the problem. I'm like, what do you do with those? The same thing you did with positive exponents. And then there's more to do with those to make it clear, but I won't hit you too hard on that today. Okay. Look on the bottom, page 191. We're going to do some practice. It's time to see if you guys remember what we talked about yesterday afternoon and this morning. I just want you to do number 1. Yeah, let's do number 1. On the try these, you can see down there the try these number 1. That's the first one I want you to do. Take it easy. Mr. A, there are so many rules. You have laws now that you're throwing at us, and we still had to remember properties, and now you're dividing. There's a lot to keep track of. So what's my suggestion for you? Oh, who said that? There you go. Bonus points for that. Actually, just practice some more. That's your reward. Practice.
Me, I'm the answer.
All right, me. What's the answer?
5x4.
Okay, get 5x to the 4th. You know why it was very simple? It's because you're dividing a monomial by a monomial. And I'm going to keep drilling this down because it means something.
That's a good oval.
Thank you. Number, and for that compliment, here's your reward. Number 3. Same page, bottom page 191, number 3. Be careful on this one because it's not as nice as a lot of them. Number 3. Okay, I rewrote it as a fraction, maybe to help some of you out to see it that vertical way, and that is going to help you out. But you're going to deal with each part. Just be careful here what you get. Yeah, okay. Don't be scared, guys. You're going to get something, and it's okay. It happens. Okay, Callie. Yeah, let's go. What's negative 21 divided by 3? All right, negative 7. What's u to the 5th, Callie, divided by u? U to the 4th. Okay, v to the 1st over v to the 1st. Okay, so it's 1. You don't have to write it there. And then w to the 1st over w to the 2nd.
What about a fraction, Callie?
Okay, how many of you got this answer right here? Okay, I'm accepting that answer. But there's another answer you could give me. And I didn't expect you guys necessarily know, but yeah, we'll try. Yeah, go ahead, Park.
Negative 7 u to the 4th and then 1 over w.
Okay, negative 7 u to the 4th, sorry?
Over 1 over w. Like, and then a fraction.
Fraction. 1 half w.
1 over w.
So here's how I would want you to write it. It's a fraction over w. Is that what you said? Or did you break it to multiply times 1 wth?
Yeah, I just kind of did that.
So combine it like this. Okay, Mr. A, these two are not equal. Or are they? Okay, I'm going to give you really the trick on how to deal with these exponents. Please listen up, because how many of you, and be honest, you're a little bit intimidated by negative exponents. Like, you don't know what it means. Because if that means all of you know what it means? Okay, okay, good. Raising hands. Oh, good. Max, what does that mean?
It means it's less than 0.
Nope. Okay, what does the negative exponent mean? Actually, this value is not less than 0.
It means division.
It means division. How?
It's like opposite on the.
Not opposite. Think of this word reciprocal. Yeah, reciprocal. I know I'm being picky. W to the negative 1st. Write this down, guys. W to the negative 1st is equal to what fraction?
1 over w.
1 over w. So Parker, that's where you got your 1 over w, right? Okay. Simplify z to the negative 3rd. Z to the negative 3rd. So when you see a negative exponent, what do you think? Reciprocal. So you're like, what? 1 over z to the 3rd. So what did change? Did the z change it? Like, did you change anything with the z? Like, you didn't change the z at all. What did change? The exponent sign and where that power went. Where's the power in this fraction? This is a fraction. It's in the you're allowed to say numerator. Where is it now? Denominator. These two are equivalent. Okay, and the last one I'm going to give you, and then we'll move on. Because let's go with a to the 2nd, b to the negative 3rd. Rewrite that as a fraction. B to the 2nd, excuse me, a to the 2nd, b to the negative 3rd. And it's one fraction. It's one fraction bar. You don't need 2. Can you do it? Okay, Jake, you look like you're ready. What'd you get?
1 over a to the negative 2nd, b to the 3rd.
Oh, Jake. You said 1 over a to the negative 2nd, b to the 3rd. That is an equivalent expression. That means that's the same thing. How many of you put that? Okay, good. That's equivalent. That means they're equal. That's true. How many of you put something different? Because there is another way of writing it. I'm cool with it. Cole? Okay, Cole said a squared over b to the third. How many of you put that? Okay, that's also equivalent. These three are equivalent. That means that they have the same value. There's another way of writing it so that all your exponents are negative. Can anyone do that? You can make all the exponents negative by rewriting it this way. I'll give you 30 seconds. I want all exponents to be negative. You can't just do that. You can. When you think of a negative exponent, think of... Yeah, and sometimes you're going like this. So it just depends. It's like a bonus question, but it's a good question. All right, I have 3 who are confident.
Hold on.
Do you have a question or an answer? Okay, hold on. You look confident, Braden. He's just reaching out. Give it to me, Mr. A. Who's not confident? How many of you have a guess? Write the guess down. If you don't have a guess, write the guess. Come up with a guess. Just throw something out there. You could be right, you could be wrong. Sorry if you're wrong. Great if you're right.
Here.
Okay, Mr. Hill.
Oh, wait, that's me. B to the negative third over A to the negative 2.
Correct.
Yeah! I am confident.
So what happened when you did that? What'd you do? Reciprocal and then change the sign of the exponent. I want you to know this right now, guys, because all these negatives might throw you off. Just because you have negative exponents, like here, here, and there, it doesn't mean the value is actually negative. All it means is that you're dealing with a reciprocal. And is that strange? Yes, but that's what happens. How many of you are okay with writing it 3 ways, or 4 ways, I guess? Rewrite it. Different way. The negative 7, leave it alone. Okay, go ahead. Rewrite it. We wrote it twice. Rewrite it 2 more times.
I have a question.
Yeah.
With the negatives, the other page is positive.
No. It's only with exponents of variables. It's only with exponents. Technically, if that had like a 2, you could bring it down and become negative 2. But don't mess with the negative 7. Negative 7 stays in the numerator every time. Negative 7 is in the numerator every time. It's a number. Rewrite it into a different form. So we had, they're both in the numerator. They're both positive exponents. So you can write it where they're both negative exponents. And you can write it where they're both in the denominator. Those are your 2 options. And you need to do both. And you need to do it in a minute. Okay, so the first option, you just put negative 7. It's there. And how do you make it where they're both negative? Does anyone know how to make them both negative? Both negative exponents. I don't care about the negative 7. Both negative exponents. Annie. I see that hand.
Would you put W next to the 7?
So how would I write W to the
Negative first.
mm-hmm.
And then U to the negative 4.
U. Sorry, that was going to be a terrible U. U to the negative 4th. That's another way of writing it. Okay, good. There's one last way of writing it. Actually, I'll write it up here because it's space. I want it where the variables are both in the denominator. I want the variables both in the denominator. You have them both in the numerator, positive, negative, both in the denominator. Does negative 7 move?
Yes.
Don't move it. So you're going to have something that looks like that. Cole.
It said negative 7 over U to the negative 4th, W to first.
And I'll just put it like this, just because we had it like that. Well, it doesn't matter. Yeah, you can switch those up, but that's it. How many of you have that? Can you rewrite it multiple ways? Yes, don't be afraid of the multiple ways. And that's what Algebra 2 is about. Wait, what? This is Algebra 1. Oh, I'm so sorry. I forgot. I'm sorry. This is next year, or 2 years from now, depending on what course you take. Okay, I think you guys are good on that. Go ahead and do number 4. Kind of change topic again. Well, not really change the topic, but...
I already did that.
Awesome.
I accidentally did.
Oh, great. What are you dividing in number 4? A trinomial by a monomial. Does that mean anything? Well, if I didn't say it. If I did say it, it probably did mean something. Yes, sir? You have an answer?
Yes.
Ratings is coming up with the answers left and right here. But I'm going to give someone else a chance, please. Sorry. Sorry, I think he doesn't like that desk.
So was the hyper today.
Yeah. He got enough rest, and he got a lot of food, so he's good.
He doesn't look well over there.
He gets taller or shorter. He slouches. Okay,
Mr. Ed, when we talk and something, so we'll pick it up.
a little bit, yeah. Sometimes it's just like just muttering, and sometimes like you guys probably get picked up. Like when Laura and Molly just blurt out answers, it's gonna pick them up. Right, Molly? She's like, yep. Laura, you gonna blur them out? Okay. Okay, Bella, read me the problem. Number 4.
3x to the third minus 12x squared equals 6x divided by 6x.
So this is what you should have done. You broke it up into 3 divisions. And what's the first fraction going to reduce to? Sophie?
1/2 x to the second.
1/2 x to the second. Okay, you could say 3/6, but that could be reduced. So always reduce it. Well, it has the same value. They're equivalent, but you didn't simplify your answer, so you want to simplify it. Elizabeth, second one.
Negative 2x.
Third, Josie.
Is it just 1?
Plus 1. That's your answer. Success? Success, yes. Answer with that answer.
You have to put plus 1.
Yes, the plus 1 has to go there because this is the third monomial, and it is 1, and it is plus 1. Yeah, it doesn't just disappear. It'll change the value. That's a good question. All right, guys. I'm going to be mean after this next problem, but I think you're ready. Okay, do number... Did we... No, we didn't do 7. Do number 7. It's coming.
No, you're going
Mr. A, long as in.
Wait, that scary looking problem? Why would I do that?
Well, Mr. A, because you're a math teacher and you like challenges.
You know, as you guys are working, I was talking to Mrs. A, and I'm like, I'm really enjoying teaching polynomials, and I'm doing it with both 7th and 8th. I like teaching math in general, but I like polynomials, and I actually like it more than I have in the past, because what I'm trying to do, and what I haven't done in the past, is I'm tying in monomials, binomials, trinomials to these lessons, and even though it seems like, well, you don't know differently, I'm bringing that up because it helps you out later on too, and I understand polynomials more. I'm like, oh, that's so cool. I love it. I love it, guys. I grow as I teach this every single year. I'm like, and I try to like spill it out on you, and some of it gets on you, and some of it comes off, but at least some of it's coming on you, and as you grow, you'll get better too. And eventually you'll get better than I will, and that is a fact. But that takes time. Maybe next year. Okay, who got number 7? Josh.
I got m to the 12th over n to the 15th.
M to the 12th over n to the 15th. I want you to write with both variables in the numerator. Go. Oh, I know, man. It's like an exercise. Like, now you reach high. Now reach low. Now reach the side. It's like Simon Says. Huh? Yes, ma'am.
on the test, are you going to have us write it in different ways?
I'm thinking about it.
No, but Mr. A, in Algebra 2, we're up for 1. You really shouldn't.
Say it again. Just
He's
no.
going to 3rd grade and taking a 6th grade math test. That's
Yeah.
what I'm saying. You know?
Like, we're...
It's just
this is Algebra 2.
Well, that'd be easy for you guys because you guys are 8th graders going into 3rd grade taking a 6th grade exam. What's wrong with that? I don't get it. That seems like you're saying it's easy. I got to make it tougher now. Okay, anyway, I think I got what you're saying, but sorry, I misinterpreted that. That's okay. Who thinks they got it? Raise your hand if you think you got it. So you were supposed to write m to the 12th over n to the 15th so that both variables are in the numerator. So did you have to move m to the 12th anywhere? No, m to the 12th stays. What happens to n to the 15th? It comes up and becomes, Parker,
Negative, or n to the negative 15.
n to the negative 15th. You should have m to the 12th, n to the negative 15th. How many of you got that? It's okay. And we'll get more practice. Last one on this page. Number
8. Don't do it. 9.
Number 11.
Better not.
Number 12.
Number 11. All right. That's cool. Number 10.
Thanks, Elizabeth.
Me? I just saw that when I was like, whoa, that's a cool problem.
Can you solve it?
I'll try. But Jack, how about you read it to me?
4a to the second, b to the third, to the second power, times negative ab squared to the third power, over negative 2a squared b squared to the second, a to the third, b to the second. No,
To the second.
the whole thing, yes.
Awesome. Verify that for me. That is important. So I'm going to move this guy out there because that means something. So that's the problem.
It's negative and then 2 in.
It's still important, but I'm glad we... Because if I do that problem, it's going to come out wrong. So 2's inside, the negative's out.
Yep.
All right, we're good with that. Good, thank you. All right, listen, very complicated, right? You got a complicated numerator, you got a complicated denominator. And what's my trick for dealing with those? Deal with the numerator. Just deal with the numerator first. Okay, so don't ignore all this. Don't do this yet. Just deal with this. And you're like, well, that's still a lot. Okay, deal with your order of operations. What do you have to deal with first? What's inside parentheses? Is there anything to simplify here or here? No. So your second step in PEMDAS is what? Exponents. And you're like, wait, they already have exponents. Yeah, but we're referring to, well, you can't do anything there, can't do anything there, nothing, but you can do something with that using the law. Okay, ready? One step at a time. We're going to deal with this one right here first. What do I do with these three values? I raise them all to the second power. So what's 4 to the second power? 16. 4 to the second power, you should know, is 4 times 4, that's 16. What's a to the second power raised to the second power? A to the fourth. So you just write a to the fourth. Whew. So far, so good. B to the third raised to the second would be b to the sixth. You multiply them. B. Okay. How many of you are okay with that? Okay, so far so good. You dealt with half of the numerator. 1/4, well, it's not really 1/4 of the problem, but at least 1/4 of what you have up here so far. Okay, I'm going to keep that here because what are you going to deal with next? The second parenthesis. All right. And here you can deal with it a couple ways, but there's a -1 if you like putting the negative ones. What's happening to all three of these values? They're being raised to the third. So it's -1 to the third. What's -1 times -1 times -1? -1. Right? -1 times -1 times -1 is -1. What's a to the, I don't know, raised to the third? What's the exponent here on a? 1. You see how there's a couple implied ones? They're everywhere, by the way. So you got 1 times 3 is a to the third. Multiply. B to the sixth. Yay! B to the sixth. Okay, we got that. Oh, man. That's, and okay, I should have said this. You are now 2/3 done with the numerator. So, do you notice that the numerator is still not as simple as possible? Can anyone make it simpler?
Oh my.
Okay, you're going to do, what's 16? I know, believe it or not, times -1. So I got -16. Okay? What's a to the 4th times a to the 3rd? A to the 7th. Now we're using the multiplication law, not the power law, because they're being multiplied. Okay, b to the 12. You're just adding those exponents. The numerator has been completed. You went from this all the way down there. Okay, I'm going to leave that here. It's kind of like, this is not my answer, guys. I'm just kind of separating. I don't have as much space as you do. I still need to know what's the denominator. Oh, what? Okay, hold on here. Let me show you because it's going to change as you deal with it. I can't simplify anything in here. Can't simplify anything in here. So now I'm going to deal with the exponents. I'm going to deal with this. And I'll deal with this after. That negative sign is outside, so listen. When the negative sign is outside parentheses, you're almost thinking of it as, what is this? And then what is its opposite? Okay? What's the opposite of all this? So let's just find all this. What's 2 to the 2nd? 4. Yay. What's a to the 2nd raised to the 2nd? A to the 4th. B to the... What's the opposite of that? -4, a to the 4th, b to the 4th. That's the opposite of that. That's hard, but not too hard. What about the second set of parentheses? A to the 3rd, b to the 1st, raised to the 2nd gives you a to the 6th, b to the 2nd. Yay! We are 2/3 done with the denominator, and you are almost 2/3 done with the problem. Fractions, you gotta love them. Okay, anyway, what do I get here? What's -4 times 1? A to the B to the, that's your denominator. -4. A to the 10th, B to the 6th. Is that as simple as can be? No, final step. You're on your last third here, which is like an easy third.
I'm done.
Okay, what is -16 divided by a -4?
4.
Positive 4, just 4. A to the 7th divided by a to the 10th. What's 7 minus 10? A to the -3rd. And then b to the... And I'm okay with this answer.
Yeah.
We're done with that one. Man, that was long. And don't worry, you only have... Oh, sorry. Let me take that back. You have 3 problems of those. No. I think I'll give you 2 of those problems. But this is what I want you to do. What's my time? Sorry?
9:06.
I think we're good. Go to... don't go with the bell because we leave at 08. So don't go with the bell. In your workbooks real quick. Workbooks. Go. Workbooks. Page 182. 182. If you guys can complete this problem, you should be pretty good. Number 20 on page 182. Number 20. Try that one out, guys, and that'll be our last problem for this morning. Oh, because we have problems waiting for you this afternoon. Bye-bye, Swivel.